All right, last thing in the chemistry unit, the mole. Okay? The mole is a unit of measurement, like a centimeter or a kilogram or a liter. Okay? It measures the amount of something. Okay? Specifically, it is a specific number of atoms or particles. Okay? Atoms and molecules are really small. Really, really small. Okay? It is impossible to count them because we can't see them. And even in like a thimble full of water, okay, it would take you almost a lifetime to count the number of molecules in that thimble full of water, even if you could see them. Okay, because we'd probably lose count. It'd be like 400,792, 400,793. What was that? You have to start over again. Okay, so yeah, we don't want to have to do that. The numbers are just mind-boggling, right? So we came up, or we didn't, but a certain person did. Okay, a guy named Avogadro came up with this idea that we could use a certain number to represent the same amount of everything. Okay, now it's not the same amount in terms of mass. It's the same amount in terms of how many particles there are. Okay, so if you look on your periodic table, okay, you'll see these atomic masses that are in here. We used them when we were calculating the number of neutrons back at the beginning of the unit. Okay, this is the mass. So if I'm looking at lithium right now, okay, the mass of lithium on yours is 6.94. Okay, that is the mass of 1 mole of lithium. Okay, in the same way that 1.01 is the mass of 1 mole of hydrogen gas. Okay, or for all of them, okay, that number is the mass of 1 mole. And 1 mole is this many. .02 times 10 to the 23. How many people have used scientific notation before? Okay, so this is new. Okay, we use scientific notation to make numbers short enough to fit on paper. If I want to write this number out in long form, it's 602 with 21 zeros behind it. That's weird. Okay, it's 602 with 21.
Ignore that vowel, please.
We will. Okay, with 21 zeros behind it. It is impractical for me to write that number out in long form. Okay, so what I do instead is I write it out in what's called scientific notation. Right? If I wanted to write, let's say, 456,321, okay, in a shorter form or in scientific notation, okay, a number in scientific notation is always a number between 1 and 9.99 with some factor of 10 attached to it. So right now, the decimal in this number is over here, agreed? If I want to make that number between 1 and 9.99, how many places do I need to move the decimal? 1, 2, 3, 4, 5 places. Everybody follow me there? Okay, so I could write that number in scientific notation as that. Obviously, that doesn't shorten that number. I'm just doing that for demonstration purposes. Okay, but we do end up shortening numbers a lot in physics and chemistry because of what are called significant digits, which you'll learn about later. Okay, but that's how you do scientific notation. All right, it's just a way of representing very large numbers a little differently. All right, so we got to understand that the mole is a unit for measuring the number of particles. Okay, and the mole works like a dozen. A dozen always represents the same number. What does a dozen always represent? 12. Well, a mole always represents this many. Okay, it doesn't matter whether I'm talking about oxygen, water, carbon dioxide, whatever. That's how many are in a mole. Same as a dozen. Doesn't matter if I'm talking about a dozen eggs, a dozen donuts, okay, a dozen people. A dozen is always the same number, 12. Okay. All right, understand the relationship between moles, mass, and molar mass. There's a formula that goes along with this. So we are going to flex and work out those atrophied algebra muscles that you have done nothing with for the last like 2.5 months. Okay, we're going to use those a little bit. Okay, I'm going to go over how you manipulate an equation using algebra, just as a quick reminder to you on how that works. Okay, and then use the mole equation to solve problems. Okay. The good news is there are only 4 ways for me to ask you a mole equation problem. Okay? I will show you all 4 ways each day for the remainder of the unit. So you will have many examples of the only ways I can ask the mole equation problem. If you watch the podcast and go over them repeatedly, you'll be fine. Okay. So the idea of the mole. Okay, we can express the amount of something in terms of mass. Okay, we can say I have this many grams of water, okay, or this many grams of sodium chloride or whatever. That's a practical way. Or we can use moles. Okay, moles tells us a little more specifically exactly how many particles are there, which is important if we're balancing chemical reactions and doing what's called stoichiometry. Okay, you won't learn about stoichiometry until Chem 20. Okay, but you need to be able to use the mole equation in order to do it. What stoichiometry allows you to do is, based on the mass of your starting materials, you can calculate how much of each product in terms of grams you would get. Okay, so if I had a reaction like, well, let's say like this. So I had this is one that like environmentalists use all the time in order to calculate the amount of carbon dioxide being pumped into the air, okay, by a single tank of fuel. Right? So they would calculate the mass of the fuel. And then from there, they could use that to calculate the mass of carbon dioxide that would be put into the air. Okay? They would know that because they'd have a balanced chemical reaction. Okay? So this would be 2 and 12 and 18 and 24 and 18. 21. All right. Okay. So they would say, all right, for every 2 molecules of this, I'm going to make 12 molecules of this. All right. And from there, they could calculate for every gram of this, how many grams of carbon dioxide were going to be produced in a chemical reaction. That's where the mole equation becomes practical and useful. Okay. They can do those sorts of calculations without actually having to do the measurements. Okay. It's especially useful when gases are produced. Okay. All right. So, because we can't possibly count particles, we use a representative number, in this case, the mole, which we abbreviate for some reason because mole is too long to write. So we use mole. You laugh. Guys, we are a society that has an abbreviation for at, because at's too long. Okay? Yeah, we're really lazy. Okay. So in the same way that a dozen represents 12 of something, the mole always represents this many. This is Avogadro's number. Okay? You won't have to memorize it, but you'll end up memorizing it because you learn it, you use it so much, but it is on your test. Okay? It's like on the front page of your unit exam. It's on there as a given, so you don't have to memorize it. It's on there. Okay? That is how many are in a mole. Doesn't matter whether it's a mole of water, okay, mole of oxygen, mole of iron. That's how many particles there are. Okay. Everybody with me so far? Okay. Now, the mass of 1 mole of a substance is known as that substance's molar mass. Okay? So the mass of 1 mole is molar mass. For elements, those are all on the periodic table. It's easy. We just have to look them up. How do I calculate the molar mass of a compound? I add all the different parts together, okay? Because obviously I can't find compounds on my periodic table. It only has elements on it. So I have to take the mass of the elements and put them together. So if I'm looking at water, for example, okay? Water is H2O. It's got 2 hydrogen atoms and it's got 1 oxygen atom. All right? So if I want to calculate the molar mass of that, I would take the molar mass of hydrogen, which is 1.01, and multiply it by 2, because there's 2 of them in here, and add that to the molar mass of oxygen, 16. Okay, which means that 1 mole of water has a mass of 18.02 grams. Okay, we always write molar mass as grams per mole because it's the mass, grams, of 1 mole. Everybody follow there? Okay. that look like that'd be a terribly difficult calculation? No. Incidentally, you're going to need a calculator from here on out in this unit. Okay. You can use your phone for now, but obviously on a unit exam, you may not use your phone. In fact, I collect the phones in a pail, okay, on exam day. So make sure that you have a real calculator. It does not need to be a TI, whatever we're on, okay? It just needs to be a scientific calculator so you can do the exponents, all right? So make sure you've got at least a dollar store or Wally World calculator. Okay, like I said, it doesn't have to be fancy. Okay, it can be like a $5 calculator. It'll do the job. Okay, everybody follow what I did there. All right, let's try another one. Let's try. Try calcium hydroxide. A little trickier. Okay, the real trick to doing this isn't the adding up of the numbers. That's easy. Okay, the trick to this is being able to read that formula and know how many calcium are there, how many oxygen are there, and how many hydrogen are there. Okay, how many calcium here? 1. How many oxygen here? 2. How many hydrogen? 2. Okay, got to be able to read those so that we can calculate things properly. Okay, so when we're calculating this one, calcium is 40.08, I believe. Okay, oxygen is 16, and there's how many? 2. And there are 2 hydrogens, so okay, if we add those all together, whoa, that's not the thing I wanted. Okay, so we got 40.08 plus 32. That's 16 times 2. Whoop. Okay, plus 2.02. That's 2 times 1.01. All right, so we're looking at 74.10 grams per mole. Okay. Oddly enough, on a unit exam where I have a mole equation question, the place that people mess them up is in writing the formula. They do all the math, all the hard stuff, okay? And I'm doing that little quotation thing because math isn't hard. People are good at math, inherently good at math. You might not believe it, but it's true, okay? And I'm one of those people who believed his whole life he was bad at math. The thing that people screw up is I give them the name of the compound in words, and they don't get the formula right. And then all their math is right for the wrong formula, and then they get the whole question wrong. Okay? So it comes back to that whole idea of you got to be able to do the basic stuff like swaps and drops and writing the chemical formulas properly, or this other stuff is harder to do. Okay? All right, there's 5 compounds there. I want you to calculate the molar mass of each one per mole. So we're finding the mass, not weight, because weight and mass are different. Okay, we're finding the mass of 6.02 times 10 to the 23 molecules of each one of these. Okay. All right, let's have a look at the first couple here. So for our first one, we got sodium chloride, okay, and sodium is 22.99, is that right? Okay, how many sodiums are there? Just 1, okay? And we're adding that to chlorine, which is 35.45. Okay. Oop. Man, it seems to be getting less and less sensitive. Okay, 58.44 is our overall mass, and that is in grams per mole. How important are units? They're crucial. If you don't put units on, or the units are wrong, the whole answer is wrong. Yeah, that sucks, but it's true. Okay, so make sure you have units on your answers. right, and let's look at iron 3 bromide here. And so iron's like 58 point something, right? 55.85. Okay, how many irons do I have? Difference in, no, because those are ions, right? And the difference of one electron, which never gonna be able to measure. Okay, 55.85, one iron, and there's 3 bromines, which are 79.90, is that right? Okay, times 3. Okay, 295.55 grams per mole. How many people have done number 3? Okay, so look at that one too. So we got 2 phosphorus in there, and phosphorus is 30.97. 30.97 times 2 plus 5 oxygens. So 16 times 5. All right, so we're looking at 141.94 grams per mole. Okay. Now, when we start getting the polyatomic ions in there, that's when things start to get a little bit hairy. Okay. How many nitrogen do I have in here? 2. All right, so I'm going to have 14.01 times 2. That takes care of my 2 nitrogens. How many hydrogen do I have? 8. So plus 8.08. Okay. And then I have how many sulfur? 1. It's 32.08. Is that right? 07. Okay. And how many oxygens? 4. So that should be 16 times 4, 64. Yeah. All right. So we will have our nitrogens, 14.01 times 2, okay, plus 8.08, our hydrogens, plus our sulfur, plus our oxygens. So 132.17 grams per mole. And for our last one here, all right, we got scandium, which is a pretty rare one, 44.96. Okay, and there's 2 of them. How many carbons are there? 3. So 12.01 times 3, and there's how many how many oxygens? Sorry, 9. 44.96 times 2 plus 12.01 times 3 plus 16 times 9. All right, 269.95 grams per mole. Okay, everybody fairly comfortable on how to do that? It's not rocket science. It's part of rocket science, but it's not rocket science on its own. Okay, yeah, so it's basically just looking them up on the periodic table, figuring out how many they are, add them up. Okay. All right, moving on. So when we look at a chemical reaction, and this is just kind of review here, okay? So that it kind of goes along with the mole equation. I got to be able to tell how many of everything I have, right? I have 2 nitrogens. I got 6 hydrogens, okay? And over here I've got 2 nitrogens and 6 hydrogens. Being able to interpret the little numbers and the big numbers is crucial if you're going to do mole equation calculations correctly, okay? This leads into stoichiometry, which is what I was telling you about at the beginning of class, okay? If I know that I have one mole of nitrogen, okay, that's going to have a mass of 28 grams. Okay, if I have 3 moles of hydrogen, that's going to have 3 times 2. Okay, that's going to be a mass of 6 grams. Okay, and then over here, okay, with my ammonia, well, I'm going to have 34 grams of products in the same way that I had 34 grams of reactants, okay? Conservation of mass still holding true there, right? If I had more products than just the one, okay, then I could break them up and I would say, okay, well, I've got this many of this one, this many grams of this one, this many grams of that one. Like I say, that's something you're going to take in Chem 20. All right, so we're going to skip that over. All right, so this is Avogadro. Kind of looks like a mole. I think it's more the cut of the suit, but it's like got a weird collar. No, that's him. Yeah, that's what he looked like. Well, yeah, like like a mole, they got the eyes that barely don't open, right? And, he was the ladies' man, yeah. The mole equation. Okay, the mole equation allows us to calculate a couple of things. We can always calculate molar mass because we always have the periodic table. We're never going to use the mole equation like you see here to calculate molar mass. It's just not, there's no point in doing that. Okay, but it does allow us to calculate the number of moles or the mass of something, okay, based on its molar mass and how much of it there is. Okay, so the mole equation goes like this. N, which is the number of moles, equals little m, mass, over big M, molar mass. This is the logic of chemists. There are 26 letters in the English language. They have a 3-variable formula that uses the same letter twice. And the only other letter is the one that sounds like the letter they use twice. N equals m over m. It's a little bit confusing. That's chemists for you. Okay, so N is the number of moles. Okay, little m is the mass, always in grams. That's the key thing here. Okay, it's very rare that you would get that given to you in kilograms. Okay, but m is the mass of the material, and that is always in grams. Because in chemistry, they deal with small things. In physics, we deal with big things. So everything's in kilograms in physics. Okay. And m is the molar mass. Big M is the molar mass of the material. So capital M because it's 2 little m's, molar mass added together. I don't know, whatever you got to do to remember it. Okay. How many people remember how to manipulate an equation? Well, just how do you generally move things around? Okay, a few hands if you're like, okay. Probably some of you are thinking about maybe using. Where is it? It's not in here. Okay. I have my rant. I have a rant every year on this. How many people were thinking they might draw one of these? You're wrong. You will never, ever, ever draw one of these because that is not how you do algebra. I hate triangles. I hate them. Okay? And they should never be taught to you because they are a crutch. And they stop working right here in Science 10. Because you, later on in Science 10, will have to use this formula. Got a triangle for that? Doesn't work. There's more than 3 things in it. Okay, and it's got an addition, or sorry, a subtraction operation. The triangle won't account for that. Triangles suck. Okay, they're useless. So you're going to stop using them today. Okay, I don't know who teaches you that crap, but I tell you, I want to throttle them. Okay, all they're doing is crippling your math ability. Okay, we're going to teach you how to do it because it isn't hard. I can do it, and I am awful at math. Okay, okay, I teach physics, and I'm awful at math. Okay, you can do this stuff. Trust me. There's 2.5 rules you need to remember in algebra. Okay? The first rule is if you want to move something, you do the opposite. So if you're multiplying it, you divide it. If you're dividing it, you multiply it. Okay? That is the first rule of algebra, rule number 1. Okay? This isn't in your notes. You might want to add it. If you want to move something, do the opposite. Okay? Do the opposite mathematical operation is what we mean by that. The second rule of algebra is what you do to one side, you do to the other. Okay? The half rule, which you won't even use in the chemistry unit, okay? Rule 2.5, okay, is to move what is not attached first. Okay? And by not attached, I mean not attached to what you're looking for. Okay? I'll show you what I mean here in just a sec. Those are the 2.5 rules of algebra. Some people say there's 3. I say there's 2.5. Just seems like it's less obtrusive when it's 2.5. I don't know why. Okay? All right. Let's say right now I want to solve for little m. So black m. I want to solve for black m. How am I going to get black m by itself? Awesome. Right, multiply both sides by the molar mass, the big blue m. Okay, so if I'm doing that, that just means move it over here. Okay, m times n equals little m. All I did was follow these rules. I wanted to move m. Okay, I wanted to move big M. I was dividing by m, so I multiplied by it. And I multiplied both sides by it, because realistically, what I did here was this. I multiplied both sides by big M. Okay? When I multiplied this side by big M, okay, what's M, big M divided by big M? 1. That's why it cancels. Okay? It doesn't go away. It doesn't disappear. It just becomes 1, and multiplying anything by 1 is anything. Okay? And then I bring it, and I do the same thing over here. Okay? Guys, honestly, that's the only manipulation of this formula you're ever going to have to do. It's set up to calculate n. You're never going to use it to calculate big M because you get that off the periodic table by adding numbers together. Okay? That's the only manipulation of that formula you'll ever have to do. Okay? Is to be able to solve for little m. Okay? So we followed the first 2 rules in order to do that. Now, just as a little quick algebra thing. Okay? Let's say I have this formula. How many people have looked at this in math already? Okay, so a few of you are doing graphing, y equals mx plus b. If you haven't, don't worry about it. Okay, let's say that I want to solve for m. So I need to get m by itself. What should I move first? Right, I'm going to move b first. That's the half rule. Move what's not attached to what you're looking for first. B is not attached to m. All right, so to move b, I go back to rule number 1. If I want to move it, I do the opposite. I'm adding it right now, so I'm going to subtract it. Well, b minus b is nothing, okay? And I'm going to have y minus b equals m times x. I want m by itself. What do I do with x? Divide by it. I'm multiplying by it right now, so I do the opposite. Okay? I divide both sides by x. X cancels there. X comes over here. Okay? Honestly, guys, like to get through high school physics, that's all you're ever going to have to be able to do. That's why I can teach it. Okay? Bad at math, but I can do this. Okay? It's grade 8 algebra. Remember those 2.5 rules, and you can't go wrong. Okay? All right, we are going to look at least one example here of the mole equation. Okay, before the bell goes, we should have enough time to do that. Okay, I don't know if that example is in your notes, so you might need to write it down. Okay. I want to calculate how many moles of calcium chloride are in 90 grams. So if I'm looking for how many moles, which part of the mole equation am I looking for? N, right? Okay, remember the mole equation is number of moles equals mass in grams over molar mass. Okay, so I'm looking for N. They tell me something in grams, so that means they gave me little m. And what else did they give me? Sort of. No, I'm going to be looking for that. But I know what compound I'm dealing with, so what can I calculate? Big M, right? I can calculate molar mass because I know what the material is. I can go to my periodic table and calculate molar mass, right? So calcium chloride, CaCl2, is going to be 40.08 plus 35.45 times 2. All right, that should be 110.98, I think, grams per mole. This is in grams. Okay, with me there? Okay, I've calculated my molar mass. So I took calcium, 40.08 grams, okay, plus 35.45, the two chlorines, okay, added them together and I get 110.98 grams. I'm pretty sure it's 110.98 grams per mole, okay. Now what do I do? Exactly, solve for N. Divide 90 grams by 110. Do I have a full mole or do I have less than a mole here? I have less than a mole. 1 mole is 110.98. 1 mole, this is 90, so I have less than a mole. I'm going to get a decimal here. That's okay. So 90 grams over 110.98 grams per mole. You don't always have to put the units in. I'm just doing that for today. So 90 divided by 110.98. All right, so we're looking at 0.81 moles. 2 decimal places will be fine. Okay. That's as easy as they get, because you didn't have to manipulate the equation. Everything was there. The formula was written out for you. Okay. When we get a little more into this, it would be I would give you the name. You would have to write the formula, then calculate the molar mass. Okay, things like that. That is where we are headed into tomorrow. Tomorrow I will do the other 3 ways that you can use the mole equation. Okay. We got a short class tomorrow as well, I think. No, we have mass tomorrow. All right. A couple of things that we need to do here. Okay, we need to look at where would you get your marks from in a question like this? Well, you would get 1 mark for your givens. That includes the calculation of the molar mass of that material. Okay, you would get a mark for the plugging in of the numbers, and you would get a mark for the answer. Okay, that would be a 3-mark question. Okay, these can be, when we start getting into more complex ones where there's a couple of extra steps, they can be up to 4 or 5 marks. Okay, but for right now, that's 3 marks. All right, everybody follow how that one worked? Okay. Write that one down. I'm going to show you how this one works. Okay, like I said, there's only 4 ways I can ask you a mole equation question. I'm going to go over all 4. I probably won't get through all 4 today. Yes, we are solving for little m in this one. Okay, what is the mass? So mass is little m. That's the thing that's unknown. Okay, of 4.5 moles, that's N, of magnesium bromide. Okay, and this is the way I would give you this question. I wouldn't give you the formula. I would give you the name. If you don't drop and swap this correctly, are you going to get the question right? No. Even if you know how to do mole equation questions, if you can't write the formula correctly, you won't get it right. Okay? You'll do all the math for the wrong compound. Right? So, big M is for magnesium chloride. That is a +2 and a -1. So we're looking at bromide. Sorry, bromide, Br2. Still the same thing, just Br. Okay, so we're going to have Br2. Okay, got to remember to drop and swap. And that it's bromine and not chlorine. All right, so we got magnesium here. Magnesium is 24.31. And there's only one magnesium. And there are two bromines, 79.9 times 2. 24.31 plus 79.9 times 2. 184.11 grams per mole. Okay, there's our first mark. We've calculated our molar mass and written down our other givens. I am being asked to calculate little m. The formula is not set up for that. So what do I need to do? I need to manipulate. I need to move big M away and leave little m by itself. So since I'm dividing by big M, I will multiply both sides by big M. And it will cancel on one side and appear on the other. Now I can plug in my numbers. So 184.11, that's big M, multiplied by the number of moles, 4.5. All right, so we're looking at 828.50 grams. No, yes, grams. Yeah, we were calculating mass. Okay, so it got the right units there. Always double check that you got the right units on your answer. Okay, so this one, you got to mark for the givens. You got to mark for your manipulation. Mark for the numbers being plugged in, and mark for the answer. So that's a 4-mark question. Okay? Everybody with me on that? All right, we will do the other two tomorrow. Now, tomorrow,